Yeah, so the recording has started. Today we'll be talking about language LLM agents and how we can implement them firstly using plain Python and then using LangChain models. Now, before we talk about LLM agents, let's try to understand what they are. Let me share my screen. Yeah, so agents are like tools for LLMs. They allow LLMs to access Google search, perform complex calculation using Python, and even make SQL queries. Basically, it enhances abilities of language models. Now let's talk about implementing one using let's using plain Python as it is. Now one thing we need to know is that we'll be for first thing we would be using GPT 3.5 as base for most of our models for most of the agent work. So you need to have an OpenAI key. This is a class which allows us to control the chat between a user and the GPT. Now, one thing to keep in mind is that the nature of a conversation for a large language model goes that if I ask model something and then the model responds. Now, if I want to question the model regarding its response, then I would have to send the entire conversation back to it. So that this logic is very important to keep in mind, and it is being handled by the message function over here. Next, we describe what GPT can do. Now, we provided that whenever we create a prompt, it should run through a loop of thought, action, pause, and observation. And then we specify what is thought, what is action, what is pause, and what is observation. Then we give it that you are only allowed to perform certain actions. Now, each action will be associated to a function which it would run on the system running the agent. So GPT would provide code that would run on the system, and that would enable GPT to do things it cannot, like access internet and stuff like that. So here we are looking at two examples, two actions. One is calculate, other is Wikipedia. So what calculate does is basically given a mathematical problem, it will solve it. And second, Wikipedia, what Wikipedia does is given a topic, it would look for it on Wikipedia and find the answer from Wikipedia. Now we defined we even specify to the GPT that the average conversation would look like. What is capital of India? GPT, the thought would be I should look it up on Wikipedia. The action is Wikipedia because as I said, it will be only allowed to do two actions, calculate and Wikipedia. So the action is Wikipedia, goes through Wikipedia, finds the answer, and gives us the answer. So this is what a sample conversation should look like. This we are telling it to GPT. Next, we build a function to like take user input. So what we will do is we'll take a user input, ask GPT to extract actions from it. Once we get what the action is, it will also find out what the parameters for that function would be. We would extract those parameter for function. We would extract the action, map it to a function which we have already defined, and then run them. So before I go deeper in this code, let's look at a Wikipedia function. So this Wikipedia takes a parameter q, and what it does it will go through whatever is the q is nothing but topic for which you have to search. So it will go on that Wikipedia page, get the contents of that page, and just return it. That's what it is doing. Then calculate, basically it will evaluate any numerical Python string. So these are the two function, and now we map the action Wikipedia to our Wikipedia function and the action calculate to our calculate function. Now let's come back to query. So we specify the max number of turns to be 5. That means you can go through the loop 5 times. Now what we'll do is first, whatever is the question, we pass it to GPT. Once we get the GPT, then once we get the response, we will look for actions in it. What GPT identifies it as action. And then if action exists, then for the action, we'll get the inputs. And if action is something unknown, then you raise an exception. And then after that, you find the observation. The observation will become the next prompt because this is a loop. And this goes on till the time you have no, you till the time you cannot identify any action in the prompt. Now let's look at an exam. Let's look at an example. So I want to ask GPT who discovered neutrinos. Now these are a subatomic particles. So the GPT looks at it and it realizes that the action it has to perform is Wikipedia. And the what Wikipedia, what should it search for Wikipedia? If you look the query Q is the topic which you want to search. So that would be neutrinos. And then it runs the Wikipedia code, which basically gets the article. We pass it again. We pass it again through the loop, and then again we get the answer as neutrinos are the first discovered by Clyde Cowan and Frederick in 1956. Next question: Who was the first person to solve the cubic equation? Now, here's the thought. It feels that it should look up Wikipedia. Then it looks up cubic equation in Wikipedia. Then now here we got this. Now we again have to find okay the solution to cubic Wikipedia because who solved it? Again it goes through the loop. History of cubic equation. Again it goes through the loop and then it finds the answer. And now the second function which we had defined, the second action which it could perform was evaluate a simple mathematical expression. Right. So now we say what is 5 plus 95. So it finds out what should it do. It should run the action calculate. And then it would call this function, the calculate function, passing it 5 plus 9, and you would return 5 plus 95 and you would get the answer. So these calculation and this searching is not done by Wikipedia, not done by GPT, but our agent that allows GPT to use it. So as you know, GPT cannot access internet. Now, how is it going to get access to the Wikipedia pages? Our agent provides the access to Wikipedia pages to it. And now let's look at LangChain implementation. Now, once again, we'll be using OpenAI large language models. Firstly, we create a function which allows us to run the query, and we also keep track of number of tokens you're using for each query. Next is, so right now, first thing we're going to do is we're going to pass a database to the large language model and our agent. So our agent would be responsible for giving the database information to GPT and running the loop, calling it again and again. Now, the idea is that you have a database and then you ask the model or the agent, you ask the agent to find out who who or what or any questions that they could like that could be answered through the database. So we create a sample database using people, weight, height, and date. This is SQL Alchemy. Then let's look at a zero shot react. That means the agent has not seen anything like it before. The first time it is seeing it, it will try to respond to it. So we create an SQL agent, passing it our main GPT-3 as large language model to be used. We specify the agent type as zero react description. And then we pass what is the average weight of a person on a particular date. Now you look at the thought, I need to query the database for the average weight of person on a specific date. Now what is the action? The action is SQL DB query. It comes up with a query. The query doesn't work well. The query is giving an error. Why is the query giving error? Because person1 is one of the field in the table and not a table itself. So then it uses the SQL DB list of tables to see if person1 table exists or no. So the agent is calling large language model again and again and again to get the answer, passing it context and more information as it is needed. And then ultimately it comes to the conclusion and you get a final answer. Now here we have a conversational React. So now it knows a conversation. There's a conversation happening between agent and you and the large language model. Now we specify memory. Now, yeah, the a conversational buffer. Now, simple. We are going to look at a method, and we this time we are going to focus on math agent. not agent, but allow it to use math tools. Okay. So this is what you're using, load tools. You're allowing a math tool, and you pass the math tool to your conversation agent. Now you're the an agent has the math tool to its disposal. So basically, it can do maths using LangChain and not like from its memory. Now, what is the product of all numbers from 0 to 5? It will run it. It would come up with the action. It would run this. It gets 0. Great. Nothing out of the blue over here. Now this is where things get interesting. Now let's say I'm having a conversation with the agent. I'm asking it, okay, but do the same operation, but this time for numbers between 1 to 5. So now it has to remember what the operation was previously. And this is where the conversational nature comes in. Because now it looks at it. Do I need a tool? Yes, calculator. 1, 2, 3, 4, 5, 6. It remembers the operation was multiplication. Then again, observation answer is 120. Do I need a tool? No. There is no action required to perform. So the chain stops. Now React doc store. This is same as the Wikipedia example I showed previously. But instead of us implementing the logic for getting data from Wikipedia, LangChain implements it for us. Basically, let's say, what was Julius Caesar's last word? So thought is search Julius Caesar. Could not find Julius Caesar. It was because this is the wrong spelling. You have multiple spellings, so similar topics. Then then the observation is search for the last word of Julius Caesar. The last word of Roman dictator Julius Caesar are disputed, and it finds, and then it's like, since it is a dispute, it is either nothing or you too, child. It is also you too, Judas, but that is a play, I'm not sure how real that is or that isn't. Then self-ask with chain. This is basically you would need a SERP API key for this. So SERP API basically allows your agent to access Google searches and provide that information to the language model in the back. So yeah, we are going to be running Google searches on some question. This is a sample prompt, how you would like how you can prompt it and what response you are expecting. Now let's see who discovered computer first. Now entering an agent executor change follow up. What was the name of first computer? Who invented so the name of first computer was this. Who invented it? This. So you can see it is asking itself questions and coming to the conclusion, and the finally you get John Macaulay and J. Presper Eckert discovered the first computer, invented the first computer. So that's about it for this presentation. Thank you.